Inspection software. So yesterday we've seen our reverse engineering software, that is PointShape design. And this is our inspection software, that is PointShape Inspector. So similarly, like how Geomagic has Design X for reverse engineering and Control X for inspection. And we also have a reverse engineering module and also inspection module with the different software names. So this is our software screen for inspection software. So this is like a workflow. You can see a same thing, like you can create a new file and you can open an existing file, and you can save the current working file. You can import a scan data and CAD model for the inspection, and you can delete any of them, and you can do the mesh processing, like if the scan data is in point cloud mode, you can process that point cloud also using different tools. And then polygonal, that is mesh data, so you can do all these mesh improvement tools, processing tools. And you can also delete some unnecessary data from the mesh if that is not cleaned in the scanning software. And here you can define which is your reference data and which is your scan data. You can also define, for example, in case you don't have a CAD model, but you have only two scan data of a same part. So in which one can be used as a reference, other can be used as a scan. So you can also do that using a define feature. And then you can do the alignment between a scan data and CAD data using a different kind of alignments, like initial alignment, manual alignment, automatic selection alignment, RPS, common points, datum based 3-to-1 alignment, coordinate alignment. So these are different types of alignments that we have. And then you can do a comparison, profile to profile comparison, scan to CAD. And you can also see the sectional comparison using section comparison tool. And you can also do a specific a point comparison also. You can either select those points or you can give the inputs for the XYZ coordinates, and then you can see the comparison values between the scan and CAD. And you can also see the comparison between the features in case if there is a cylindrical feature on a CAD or some spherical feature defined geometries. So you can also see the comparison particular to that reference geometry. And these are the reference geometries that you can create using PointShape Inspector, like point, vector, circle, plane, cylinder, sphere, cone. And you can also create 2D sections, and you can do measurements. So you can measure distances, angles, radius, and you can calculate the area. You can define datums for the GDNTs, and you can also do the GDNT measurement also. And here these are like a standard views, and same thing that we have in design. You can have all the standard views, and you can just rotate the part in clockwise, anti-clockwise, flip. And you can and these are the show and hide icons. So if you want to show the reference data or hide the reference data, you can click here, or you can right click on the object and you can also hide, or you can just uncheck here in the model tree or project tree. So these are the selection tools we have currently. So that is a polyline selection, custom selection, and rectangle selection. And these are like selection criteria. If you want to select only visible face, you can enable this. And if you want to select both only a front face, you can do that. And if you want to select through, then you can enable this. So this is a color bar for the comparison. So these tolerances can be changed in the options. So here we can change those tolerance values and save OK. And we can also do some other settings in the options, like with respect to CAD, scan, and selection type, colors, and color bar separation also. And we have a tool called macro that is for a multi-piece inspection. If one part has a multiple quantity, So for the first part, you can create a sequence, and second part onwards, you just need to replace the scan data and just run the macro. So the inspection sequence will be taken care by the software, and finally it will generate a report. So this is for the multi-piece inspection. I mean, same part having multiple quantity. So I'll just show you quick inspection using our inspection software. So I'm just importing a CAD. So CAD can be imported in all these formats. Our software also supports native formats like CATIA V4, V5, and .dwg, even SolidWorks files, Solid Edge files, ProE files, Parasolids. So all those native formats will be supported by PointShape Inspector apart from neutral formats. So I'm just importing CAD. So this is our CAD models. So by default, when you import, that will be considered as a reference. So you can see in the model tree. So CAD model in brackets, it's named as a reference. So this is going to be our reference model for the inspection. And now I'm importing scan. And this is our scan data, which I'm going to inspect with respect to the CAD model. So you can see in the mesh, it is considered as a scan. So now we have a scan data and CAD, and here you can see in the model tree. So as I told you earlier, you can also show hide from checking and unchecking the box in the model tree. So you can hide, and again you can show also same thing for scan. So now we have a scan and CAD. So you no need to define unless you are okay with the software consideration. So software is considered your CAD model as a reference and the scan data as a scan. So if you want to change, then you can define and change. So, but I'm okay with this because I'm going to consider the CAD as my reference and the scan data as scan. So now I directly go for alignment. So whenever you wanted an alignment, so you can always go for an initial alignment first. So after that, you can choose a particular alignment based on your drawing or based on your customer's input. So I always suggest you to do a initial alignment. So software need an initial alignment. If you have enough geometries and all, initial alignment also almost perfect. So after that, if you want to go for any specific alignment like 3 to 1 or RPS or automatic, you can do that. So I'm just going for an automatic alignment. So I'm done with the auto alignment. So now my scan is superimposed on CAD. So once you got this, so what you have to do is you have to go for a comparison. So I'm going for a comparison and say apply. So this is my comparison between a scan and CAD. So currently my tolerances are plus minus 500 microns, that is 0.5 mm. So the green replicates that it is okay zone, that means within the tolerance zone, and blue is a negative deviation, and red, yellow, orange, other things are positive deviation. So if you want, we can change these tolerances. Maybe I'll keep it 0.1 and say apply. So now you can see the changes in the color on the object. So these tolerances are always depends on the customer or customer drawings. So based on the input from the customer or from the drawing, we have to choose these tolerance values. So now we have a color comparison. If somebody wants to know a deviation at some specific point, so for that we have to go for a whole comparison and choose whole comparison annotation. So after choosing that, wherever you click, you will get an annotation with the deviation value. So these are like a simple annotations. If you want a detailed annotations, like if you want the deviation in XYZ axis also, so then again you can go to options. You can change this annotation style to detail and say apply, and you will get a detailed deviation results. Like here in XYZ axis, what is the reference position, and measured is your scan data. So this is reference and measured position, and deviation in X-axis, deviation in Y, and deviation in Z. And overall 3D deviation is 0.28. So likewise, you can also change to detailed annotations also. So I will just go to a simple type only for the time being. So this is like a whole comparison, and here you can hide this annotations if you don't want to see. And similarly, you can also do a sectional comparison, like at any particular area you want to see the cross-sectional comparison. So you can cut that portion. So this is section comparison. So you just need to select the plane. So for example, I wanted to cut along this plane. So you can also move this plane. So if you want section somewhere here or somewhere here, you can choose that and say OK and apply. And to view that comparison, just hide whole comparison and see a standard view. So this is a comparison, sectional comparison. So that black line indicates your CAD and colored lines indicates your scan. So based on the deviation, the colors will vary. So here also you can take those comparison annotations on the section also. So likewise, you can also see a sectional comparison, like if some customer wants to see the deviation at some particular section, so you can also show them this sectional comparison. And you can also see some point comparison, like here you can give the values of those coordinates if you already know, or else you can simply pick the points on the data. So I'm just picking points here. Yeah. Here, 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 and say apply. So you will get those values. And if you want to see same points on the different scan data of same component, you can also export these points. and import those points in next inspection session.
Okay.
Okay. So that is a point comparison. And similarly, we can also do a, sorry, cylinder. Select. So now I just created a cylinder. So I just wanted to do this feature comparison. So I select this reference cylinder and say apply. I'll just hide this so we can see the comparison on that particular area. So this is a feature comparison. So you can do all these four kinds of comparison once on between the scan and CAD. Like you can do a complete profile inspection. You can also do a sectional cross-sectional inspection, and you can do a specific points comparison, and you can also do a feature comparison. And you can also do a 2D measurements in this. If somebody wants to check the dimensions, we can also do that. Like, for example, if somebody wants to know the radius of this, so, so the reference in the scan is this. And similarly, you can check for others also. Radius, select. And you can also check the distances. You can take distance like between 2 points or between two entities. If you want to measure between two entities, like center to center distance, this and this. So this is the distance. So we can also choose the alignment before measuring the distance. Like if you want the dimension in x-axis or y-axis or z-axis, so you can choose that, and then you can see the dimensional value. You can pick those entities. And you can also measure GDNTs. So these are the available GDNTs we have, like straightness, flatness, circularity, cylindricity, parallelism, perpendicularity. So all these GDNTs you can measure. For example, if you want to see a flatness, you can see put the tolerance value also before selecting that plane. So when you say apply, so you will get the value. So you can see it is failed. The red indicates that it is failed. The tolerance is more than, I mean, the actual value is more than 0.5. So similarly, we can also check for parallelism, perpendicularity, circularity also. So, but for perpendicularity and parallelism, first we need to define datums. So that also we can do. So there is a datum defining option here, add datum entity. So this is my datum A, and this is my datum B. So now again I'll go back to ZDNT. So I'll say perpendicularity. So with respect to datum A, I want to see the perpendicularity of this with respect to datum A. So this is also failed. It is more than 0.5. So please note that this is a casting component. So that's why the tolerances are a little high. So that's what I mean. What you can do in this software is like you can do all the inspections, required inspections using a CAD and scan. You can also create a few reference geometries and you can create 2D sections and you can also do a GD&T inspection. So far, is it clear so far, or you have any queries?
I have a question.
Yeah, please.
Why perpendicularity? I cannot see deviations. Measure it.
Where?
Can I see deviations, perpendicularity?
Deviations in what?
Uh, perpendicular define a base A.
Okay, you want to see the actual value, deviation
Yes,
value.
yes, yes.
Okay. See, this is actual value. On the right side, you can see. So the tolerance is 0,
Okay.
and here actual value is 0.6996. So that is close to 0.7. And this will come in the report.
Okay.
Okay.
Yes.
And similarly for the perpendicularity also, you can see the actual value is 0.6414 mm.
Okay.
So any other queries?
Can you show how I can align scan data um, not best fit select entities?
Select entity. So okay, I do that.
It's very important for us.
Yeah, I'll show you that also. See, I mean, at any case, you have to go for an initial alignment. So after that, you can choose a 3 to 1 alignment. So it will ask you to pick a plane. So then it will create a plane for scan data and it will show whether it is a valid or invalid. If it is a valid, you can continue with that. If it is invalid, you have to choose some other plane. Okay.
Okay.
And then it will ask you to choose a vector. So you can choose a vector. So here it is. And then you have to take a point. So point can be a circular center also. So when you say align, so it will get aligned. Now you can see change in the alignment. So once you did this 3 to 1 alignment, again you can do a comparison, whole comparison and say apply. See the result.
Okay.
So this is your 3 to 1 comparison. I mean based on entities. So which entities you wanted to select, you just need to pick them on the CAD. So scan will be created by software automatically. And you have to see the result. Like once the scan geometry is created by software, you have to see the result, whether the pair is valid or invalid. If it is valid, you can proceed further. If it is invalid, you have to choose a different entity.
Okay.
And you can also do an manual alignment also in case there are no geometries and initial alignment or automatic alignment is failed, then you can go for a manual alignment. So you can pick some common points here. In the same position, you can pick few common points, just like endpoint alignment. Say align, and this is the alignment. So if you do comparison again, then you will get a different result. See, most of the, because the alignment is not proper with the manual element. So because I just took a approximate points and that to very minimal number of points. So my intention is to show you the different types of alignment available in the software.
Okay.
So similarly, you can also do a selection type alignment. So you can select area. Just hide this one. This, this. So using this selected area, so I want to do the alignment on my scan. So this is a common data selection. So you can also do alignment based on this. The RPS alignment, you know that you just need to pick the points. So and say align. See, it got aligned. So this is a pair point alignment, that is RPS alignment. And you can also do a coordinate alignment. So when you don't have like you can choose this x-axis, y-axis, and moving entity. You can set moving entity as your scan, and method is coordinate. You can pick origin point, maybe this. So this is your origin point, and then you can choose x-axis. This is my x-axis, and you can choose y-axis, and this is my y-axis. So likewise, we can define. And on the target also, we have to choose same thing and say apply. It will get aligned. So that is coordinate. So it can work without CAD also. Like if you want to align only scan data and see some measurements, you can use coordinate alignment.
Okay.
So those are the like, I mean, these are the different types of alignments we have. So is that clear?
It's Clear.
So do you have any other queries related to design or inspection?
Can you show how I can adjust my screenshot in a report?
Yeah, okay, fine. So what I'll do is I'll just start from the beginning because I did many things in the same, so we'll get confused. So I'm just importing the same file, CAD, scan, and do initial alignment, execute, and then some automatic alignment. So comparison, and then whole comparison annotation. So I'll just hide. So this is so you want this kind of snapshot in the report. So in the screenshot, you can take a screenshot, then it will pop up a new window to save that data. So for this object, I already did inspection. So I have already saved few images. So it will be there. So you just need to give the name and save.
Okay.
Okay, and after that again, if you want only a comparison screenshot without image, again you can take a screenshot just like this and save. And you can also take images for uh, superimposing, that is alignment of a CAD and scan. For this also you can take a screenshot and put it in your report. And you can take individual image of scan and also CAD using screenshot option. So finally, you just need to click on the report. So this is a default report page. So on the main image, if you want to change this image with the existing one that you have taken during the inspection, so you just need to click on here and it will ask you to choose that image. So just go to the location where you saved those images. And for example, this is my main image. So I wanted to keep this image. And if you want to add any additional images in this page, you can click on this plus button here, additional images, click on here. So I wanted to add this, this, and this. So these four I wanted to add. So now your report will be, so this is your comparison, scan, and your CAD and other comparison images with annotations.
Okay.
So likewise, you can create a report. When you say create, it will ask you to give the name for the report. So there are two formats that are supported for the report generation. One is Excel and other is PDF. So based on your customer's requirement, you can choose the format. So generally in India, we always prefer PDF. So I just give a name in PDF and I create a report. So I'll just show you the report that I created. So just give me a moment. It's accurate. So this is the report I created for our customer. So this is my front page. So after that, I just added a scan and CAD, and then comparison, that is color map. And these are some measurements, 2D measurements that I did based on customer requirement and with the tables. And these are the other images in different orientations. So likewise, you can add many more screenshots based on your customer's requirement. So this is a report we generated. This is in PDF format, and similar thing can be generated in Excel format also.
Okay.
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 So anything else you wanted to ask?
Can you show how I can measure it distance, radius on sections?
Sorry, could you please repeat?
Can you show how I can measure it? Distance, radius, angle, not whole part, just on sections.
Sections, 2D
Yes,
section.
yes.
Okay. So you have to go to a 2D section and just select the plane. For example, if you want to have a plane here,
I see only report.
sorry, I just share. So I'll just cancel. So this is your data. So after the alignment, so you just need to click on 2D section, and you can select the plane wherever you want the section. And same thing like a cross-sectional comparison. Here also you can choose section wherever you want and say apply. A 2D cross-section will be created here in the reference in the project tree. So just hide your scan and CAD. You can see the section. And this is the section you have.
Okay.
So this black line is your CAD, and this blue colored line is your scan. So you can measure between 2 points. So this is a distance. And similarly, you can also measure from here to here. This, you can change this alignment to Y, or you can change it to Z also. So before measuring, you can choose that. So for example, this is Y distance. So I'll go for Y, and I'll pick same points, maybe on this here to here. So you can see Y distance.
Okay.
So same thing, like you can also measure angles. So this is an angle.
Не похоже.
And you can also measure radius. Select. and radius. So likewise, you can do measurements on 2D cross sections also. You can also create reference geometries on the 2D section, and then you can do measurements, either angles or distance, linear distances or radius. So all those things can be measured on 2D sections also.
Okay, thank you.
Okay. Thank you. So how's the software? I mean, do you feel this is good, or you want to have some any other features, the inspection software? Hello.
I think good software, very easy. Do you have plan make Russian language interface?
Russian English interface in the software?
Russian language.
No, I didn't understand.
Uh, have you plan make Russian language interface? No, translate to Russian language interface software.
Acha, in software you want a Russian language interface. So right now we have only this one, I mean English. So you wanted to have a Russian interface also.
Okay.
Okay. Maybe I'll update to our development team. So I'll tell them that if it is possible, they will definitely do it.
Can you show how I can comparison two scan between without cat model?
Two scan datas.
Yes.
Okay. No. Two scan this. Both scan this. So
Это должен...
there are two scan datas.
Да, только так.
So you can define. Wait a moment, I'll do one thing. So go to define, you choose one as a reference and other, like maybe I just remove here, I'm just removing. So I'm choosing this is my reference, so it is added, and both the datas with the same name. So after that you can do the alignment, because I mean both are same files. If you have a different files of same component, then you can see the differentiation, but I'm just explaining you the procedure.
Okay.
Execute, and then you can do a automatic alignment. After that you can do a comparison, say apply. because it is 100% matching because the data is same, both the
Okay.
reference and scan. That is why it is showing 100% green.
Okay, I see.
Yeah. So you just need to do one thing that after importing both scan data, you have to define which is reference and which is scan. After that, the procedure is same as your regular inspection process.
Окей. Надо будет определять, какой скан.
So do you have this PointShape inspector with you?
I have trial license 2 week.
Okay, but that is only for design, or you have it for inspection also?
I have inspections. PointShape inspector. I already use it.
So, I mean, if you have a license for both, maybe I just recommend you to have a hands-on session. So that when you do hands-on, I think you got only for the point shape design, not for inspector and all, because they, yeah, I think yes, you got a license for inspector also for 2 weeks. So I just saw that mail. So they have given licenses for inspector, design, and editor. So maybe after you install the software in your computers, maybe your team can do a hands-on and let us know the feedback. Like if you have any queries, because I know in a one-day training you cannot learn everything. Maybe while doing hands-on, you may get some other queries or some issues. So please let us know that. So we are here to help you. I mean, you guys already have my mail ID. So you can send me through mail also, or you can, or we can have a similar kind of a session through Teams to clarify those doubts and all, both in inspector and design.
Okay. Can you... Как это писать будет в чат? Can you give me your email?
Yeah, I'll
I think в chat.
yeah, in chat I'll just give you. So I just sent my email ID in chat.
Okay.
So at any point of time, you can write to me, maybe based on our convenient timings, because I mean, our timings are little different. We are 2.5 hours ahead of your timing. So maybe based on convenient timing, we can connect each other.
Okay, we will try to make one project and report by ourselves, and we'll give you feedback after.
Okay, that's great.
I sent you email for test.
Yeah, no issues. You can do that. So I mean, if you have any other things to be asked, you can ask me now also. No issues. maybe based on yesterday's training about design and for inspector. Or if you want to have some hands-on session, after that you want to connect with me again, I have no problem, based on your convenience.
Okay, okay.
So I think that's it from my side for today. So you can continue with the hands-on at your end and let me know. So I'll be available till 5:30 India time. Maybe for you it is 3 o'clock in Moscow time, 3 p.m. So in
Okay.
your time till 3 p.m. I'll be available. So you can also send me an email so I can connect you back. With the same link, we can join for today also.
Okay.
Okay.
Thank you for presentation.
Yeah. Thank you. Thank you for
Thank
time.
you.
Yeah. Have a good day.
Bye.
Bye bye.
Goodbye.